Hello YouTube, De-bodgery here. Welcome to EV Components Review. So on the bench is this Surron Ultra B power stage. So macro view, get up nice and close and see everything. I can bring that even closer in. Yeah, and I'm trying a different lens for this. I have a fixed focus macro lens that will allow me to get much closer in, but this one has a larger area of view, and obviously I can zoom in and out significantly to see more stuff. So it's got better focal range on it than the macro lens, but the macro lens allows me to get way in, and obviously I'm beyond the capabilities of this lens, so let's back off a little bit. Alright, so as you can see, these are Magnet Chip, which is a brand that I like a great deal, and they are 10N025 Mosfets. Which is interesting because the Surron Ultra B, I'm pretty sure it's 24S, which is like 90, let me pull out my phone and do the math here. Pretty sure that's like 94.6 volts or something like that. So, yeah, that's 98.4 volts. So, these are 100 volt MOSFETs, you know, at full charge, running at 98.4 volts. This is an interesting design choice, one that I would not have expected. You basically want to give components some worth of playroom so that if there are, like, say, spikes, over voltages, things like that, you don't blow up the parts. And the Ultra B is a 24S system, i.e. 98.4 volts at full charge. And here you've got 100 volt MOSFETs. So, interesting design choice. They are rated for 2.5 milliohms, which is not too bad, and 240 amps each. So, one of the details about this package, so this is called an M2 Pack-7P, and we've got 7 legs over here, hence the 7P, of which 6 of them are all I believe that's the drain, and this is the source on the tab up here, which solders down right here. So you've got 6 legs in parallel, and each one of those legs is 50 amps each, so maximum of 300 amps DC across those 6 legs. And this is a 240 amp MOSFET, so those legs are definitely going to be able to handle that. You know, like with the TO220 package, they're limited by the 75 amps from the legs on DC. With AC, you can go a little bit higher, like 100 amps. But still, you know, it's very, very common in the TO220 package to have MOSFETs that the die, the little chip inside here, is far more powerful than the packages. You know, like the AOT290, I think it's a 180 amp MOSFET. And, you know, here you are limited by the legs to basically 100 amps max AC and 75 amps DC. And so, yeah, having a package that's actually better than the actual die inside it is a good thing to have. And so, like in this case, 240 amps inside the die and 300 amps worth of legs, that's a good thing. Yeah, and that's obviously why this package gets used, and why I like the TOLL package, tall package gets used, and, you know, the TO263 7L gets used. Same reasons. You know, you're not limited by the package as far as what the MOSFET can do. Instead, you're limited by what the MOSFET die can do. And that's better. All right, so in my overview, I showed you the Snubbers. So here is battery plus, and here is battery minus. And then this is phase across here. You got a cap and a cap and a resistor and a resistor. So those are Snubbers right there. They deal with some specific situations where you might have some high frequency noise that runs away and things go a little bit crazy, and you rein it back in again with these little guys. Right here you got a couple ceramic caps, so this down here is battery plus, and this is battery minus right here, and that's where you want the ceramic caps to be, you know, cross battery plus to battery minus. And you want them right next to the MOSFETs, as close as you can get them, and definitely more than this. You know, I've said this many times about, like, say, well, Komodo is probably the worst. You know, just, or like, not Far Driver, but Flip Sky is also really bad. They tend to not have any ceramic caps at all, which is even worse. Just basically means that your high frequency noise on your battery bus is just running away like crazy. So you definitely want ceramic caps, and you want them very close to the MOSFETs as much as possible. I would have moved these snubbers to someplace else, like inside here, and that way I could put these ceramic caps literally right there. That would have been better. And of course I would have put 2 more right there. 2 isn't really enough. These are probably 2.2 microfarad or 1 microfarad ceramic, something like that. Yeah, this is one set of gate drives, and these gate chips, they pretty much are gone. I can't read the part numbers on anymore. That's from vigorous scrubbing with the wire brush to try to clean the potting off of everything. Can't read the most of the parts anymore. Yeah, but anyway, there's still a couple of them you can read. So like these 2 right here you can read. So these are 2127s, I believe. Let me look at that data sheet real quick here. Yeah, so they're made by International Rectifier, and they are 2127 gate drivers. So they're a single channel gate driver. So, like this set right here is like all doing low side, and those ones there are doing all high side, or vice versa. But yeah, each one is just a single gate drive, and they are current sensing single channel drivers. So I didn't read the data sheet too much to find out what that current sensing is, but it must be that they're able to change their output current based on how much gate drive they need to apply. I don't know why there's these little Mosfets in here. Ugh, excuse me for yawning. But I would think that they would have something to do with boosting current coming off of these guys before you got over to the MOSFET gates. I don't know what else you'd do with those. Yeah, you certainly don't need them on the input side going to this gate driver chip. That's just logic level signals. Nothing high current about that at all. When you see little things like this, so this is a resistor that has 0 ohms. It's basically a jumper wire. That's why it says 0 on there, 0 ohms. Anyway, when you have a metal core printed circuit board like this, you don't want to make it multiple layers. You don't want to have internal circuit traces and then surface circuit traces. So you'd have like a 2-layer board. You want to try to keep the circuit board as thin as possible. And the reason why is because, well, this stuff is insulation effectively. I mean, the copper is not, but like you'd have to put fiberglass between this circuit trace and the set of circuit traces underneath it. There'd be a thin layer of fiberglass, and that does act like an insulator. So as a result, your MOSFETs wouldn't be able to conduct heat away as efficiently as they can direct copper to ceramic to aluminum. So anyway, this is a common method to jump over one thing to another rather than using a via to a second layer of a circuit board to get a trace from point A to point B. So can't really see it too very well, but like say that little jumper resistor right there, you can see this trace right here goes right underneath it, not the other side, and this one jumps right over top of it. If you had a multi-layer board, you would like put a via right here, put a trace in the middle of the board, another via right there, and bring it back out again. So this keeps it as thin as possible, and you just use jumpers when you need to get over top of something else. That's what all these little 0 ohm resistors are about. They're just basically jumpers across one thing to another, and that's all they're doing. Yeah, like right here, so there is a trace that goes underneath this one, comes out the other side. There's a trace right here, goes through this one, comes out the other side. So they've put 2 0 ohm jumpers to allow you to put a trace underneath those 2 parts. Yep, that's what that's about. Alright, so what else do I want to show you on here? So from here to here, I measured this. This is 18.6 millimeters wide. That's a heck of a lot wider than it is on KO Moto controllers, which is only 8 millimeters. And this is supposedly a much lower amperage controller, despite the fact that I'm pretty darn sure that if you ran these MOSFETs right, you could probably take the 4 of them and easily get 500-600 amps out of them. No problem. anyway, yeah, that's definitely better than Komodo's 8 millimeters wide and claiming, 800 phase amps. Yeah, sure it is. All right, so here you've got another set of snubbers. So here's your phase bus. Here's the low side through that cap and that resistor. And here's a high side from that cap to that resistor to battery plus. So each one of these faces has got snubbers on it. Here's a couple of ceramic caps going from the battery minus plane to the battery plus plane. And they're right next to the MOSFETs where they're going to do the most good. So that placement is not too bad. Would have put a couple more of them across here so you could do the same thing over there. But yeah, snubbers are kind of in the way. Anyway, this is the battery plus post here, and so those are also battery plus as well. I measured this too, so from here to here, from one side of that piece of copper plane to the other, and that's 19 millimeters across. So that's a lot better than the rest of it, and it's got this bit of solder added to it to reinforce it. Sure it is. So once I had this under the macro lens, I could look at that right there. This is the stud that pulled up. And yeah, you can see how absolutely starved that is for solder. There is nothing on it, just a little lip on the inside of it. So this little pad right here had barely enough solder to hold that stud in place. I mean, almost enough. Let me go over to one of these other ones right here. And let me change the focal length on here so we can see that. There we go. Yeah, you can see it. All right, so let's see if I can't make the camera ads better. All right, so you can see how there is no flow from the solder pad up to the side here. It's just a 90 degree, which means it's just barely wet enough with solder to adhere these studs, and that's it. Anyway, that's why they pull up, is because the solder joint between the stud and the circuit trace is just got no solder on it, so they can't flow together. It's basically wetted about like this pad is, which is inadequate for something like this, which needs to endure the stresses of having a screw in it. So yeah, that wasn't good enough. That's a manufacturing flaw. They should have doubled the solder on those pads, and they didn't. It's enough for stuff like these legs, which still are pretty light on the solder department. But for a stud like this, it's got to handle the stress of screws in it. Yeah, it's not really good enough. Yeah, and you can see how like this here, it's almost completely flat. There's like no hump to it at all. Like it would have solder across it. Yeah, this is, it's, yes, it's silver with solder, and that's about all I can really say about it. Yeah, you can see these pads are a little bit better in some places than others, but that's just barely enough, just enough, but not enough for stuff like studs. Anyway, I think that's everything I want to show you about this power stage. Better than some I've seen. I like that it has ceramics pretty close to the caps. I like that it has snubbers, wherever they are in this one. They're down here. Yeah, there they are. I like that it has snubbers for every single one of the phases. Don't know what this resistor and this cap does in here. If people know what those do, please post it in the comments. Like that resistor and that one right there, that's about gate current, basically. This little set of pads right there, see, it goes right over to the gate leg right there. Yeah, you put that resistor across there, and that's for limiting current to the MOSFET gate so that you don't overdrive them. But yeah, this little cap and that little resistor, those I don't know what they do, because they're at every single pair of MOSFETs. Anyway, if somebody knows, kindly post it in the comments. Alright guys, I think that's everything there is to see about this thing. Yeah, thanks for your time. Take care.